Okay, so I wanted to look here on 7.3. We've done graphing. We've talked about how to rewrite exponents and logs. A couple of other things I want to talk about. It's actually at the bottom of the back of your worksheet, of your notes. Look down here. They have our basic ideas. You've seen this for all of our other families of functions we've done, right? Where they show you how the shift is. They show you the general form equation for the function we're dealing with. And so then this is the general form for logarithms. Looks very similar to all the others we've done, okay? The h shifts us left and right. The k shifts us up and down, okay? The a value of a is negative. Remember, that's where we have that reflection that then opens down, okay? So there's a couple of things about that I want to show you today to make sure that you've seen examples of it before you're set free on your homework. So let's take a look at some shift. With logarithms, you have to be very careful about what is being shifted or how it's being shifted. For example, if I have y equals log base 2 of x plus 3. Log base 2 of x plus 3. What do you think that shift is going to be? That is going to be up 3. Very, very good. This shift is saying that we're going up 3. You have to be careful because what they're saying here, remember I told you guys yesterday that log or logarithms are very similar to your trig functions from geometry, sine, cosine, tangent. Sine doesn't mean anything unless it's the sine of a number, right? Sine itself means nothing. Sine of 90 degrees now has a value, okay? Or sine of 50 degrees now has a value, okay? So same with log. Log base 2 doesn't mean anything unless it's log base 2 of a number. And in this case, it is log base 2 of x. That's the number. I'm taking log base 2 of x, and I'm then adding 3 to the end. So that plus 3 is the k value in that general form equation. Okay? Unlike y equals log base 2 of x plus 3. It's now in parentheses. They're now telling us that we're taking log base 2 of that quantity x plus 3. Okay? They're now telling us they're taking the log of that whole quantity, not just the log of x. All right? Catching the difference? Those parentheses mean a big deal. And so in this case, we have a shift going where? Left 3. Okay? So you got to watch out for that. You got to watch out for that. Are the parentheses there saying, hey, they go together? Or are they not there saying, hey, that's tacked on at the end? Okay? So just for some extra practice, let's go ahead and graph these guys. So graphing log base 2 of x plus 3, we're shifting up 3. And just like we've done all the time on every function when we've dealt with shift, we then ignore the shift. Once we realize what it is, we get rid of it. And so I'm actually plotting points for y equals log base 2 of x. And to do that, to plot points, I've got to rewrite that in exponential form. The base of my logarithm is 2, so the base of my exponent is 2. Remember I said that the log is the exponent. So the log equals the exponent, so the exponent must be y. And so 2 to the y power equals x. We're going to plot points. And I've said that it's easier to plug in for the y, right? Because that's the exponent. So if I plug in for y, 2 to the negative 2 power. Okay, 2 to the negative first power. 2 to the 0 power. 2 to the first power. 2 squared. And I could probably keep going, right? What if I plug in 3 for y? What's 2 to the third power? 8. That's still on my graph. And so I want to plot as many points as possible. Okay? So plotting those points, 1/4 on the x-axis, down 2 brings me somewhere right around in there. And then 1/2 on the x-axis, down 1, 1 on the x, 0 on the y, 2 on the x, 1 on the y, 4, 2, 8, 3. All right, so we can see from our points that our asymptote right now is the y-axis, right? It's opening like this. Now, with the shift, if we're shifting up 3, is that shift up or down going to change that asymptote? No. So everything is just going to get shifted up 3. Oops, I missed a point. There we go. All right, so there's our points, and our graph would look something then like this. Just like we did with exponential functions, please make sure when you're graphing these that you are going edge to edge on your coordinate plane. Okay? Make sure you're graphing edge to edge. All right, questions on example 1? No? Doing okay? Making sense? Let's quickly graph example 2. The nice thing about example 2 is that once we've identified our shift and once we ignore the shift, it's really plotting the exact same points as what we just did, right? So always keep your eyes open when you're working on quizzes, tests, or even homework, because you might have already done the work. Like this example, we have already done all of this work.
Can you go back to number 1 real quick?
Do you have a question?
No, I just want to see.
I'm going to show it right now. Give me just a second. Just a second. Let me put this in here. So we have 1/4, 1/2, 1, 2, 4, 8. I know all of that because that's the work that we just did from example 1. We were plotting the exact same points, even though our shift was different. All right, so now that we have our information, we're going to plot our points just like we did in example 1. So 1/4 down 2, 1/2 down 1, 1, 0. 2, 1, 4, 2, 8, 3. But this time, we're shifting left 3. Now, by shifting left 3, is that going to change our asymptote?
Yes.
Absolutely. Because our asymptote is vertical, left and right shift moves it. So moving to the left 3, we have our asymptote going here. So then each one of those points needs to get shifted left 3. Any questions? All right, so let's take a look again. You guys can flip back to your last page in your notes. They're at the bottom. They give you that general form equation. They say that y equals a log base b of x minus h plus k, right? That's that general form equation they give us for logarithms. In every single problem we have done up to this point, a has always been 1. Positive 1, right? What happens if that's something else? Well, they say that if it's negative, our graph is going to have a reflection, just like it always has. Remember, parabola is opening up, the a was positive. If the a was negative, the parabola opened down, right? Same thing goes here. Let's go ahead and look at y equals negative log base 3 of x. Okay? We'll leave the shift out of it for now just to simplify it so we're looking at the one thing. All right. So first thing is first here. The translation from logarithmic form to exponential form doesn't have a being anything other than positive 1. Right? And so the very first thing we would need to do here is to get rid of that negative out in front of our logarithm. How would I do that? Divide it out. Right now it's negative 1 times log base 3 of x. So divide it out. So we now have negative y equals log base 3 of x. Now we can go through and rewrite this in exponential form. The base is 3, the exponent is negative y, and that will equal x. Okay? And so really all this does for us now is it changes slightly how we're going to plug in our points. Because now if I'm plugging negative 2 in for y, I have 3 raised to the negative 2 power. Makes it a positive 2. So I really have 3 squared, which is 9. Okay? And I have 3 raised to the negative 1 power. 3 to the first, which is 1. I have 3 raised to the negative 0 power. Well, there's really no such thing as negative 0. Negative 0 is just 0. And so 3 to the 0 is 1. 3 raised to the negative first power is just 3 to the negative first.
1/3,
and then 1/9. Okay? And so now if I plot those points, 9 on the x, negative 2 on the y, 3 on the x, negative 1 on the y, 1, 0, 1/3, 1, and then 1/9 I really can't graph, so I'm not going to mess with it. But notice what's happening now. Now, the y-axis is still our asymptote, but the graph has flipped, just like we expected it to from what we did in the past. Right? Rather than going this way, our graph now goes this way. Questions? No questions. Let's do something just a little bit more complex. Let's just see what happens here. And we don't need to do the whole graph unless you guys really want to see it, but what I want to know is what would you do if you had y equals, let's say, negative 2 log, it doesn't have to be negative, it just could be a 2 out in front. If you have some other number other than 1 out in front, what's going to happen? Let's say we have base 2 of x. Okay? What's going to happen in this case? Well, again, just like the previous problem, we've got to get rid of that negative 2 out in front in order for us to be able to rewrite it in exponential form. So I would have to divide everything by negative 2. So it's negative 2 times log base 2 of x, divided away. I now get negative y halves, negative y divided by 2, equals log base 2 of x. So now how would I rewrite this in exponential form? Two raised to the negative y halves power equals x. And so again, all this changes for us is how we plug, or what we do with these numbers when we plug them in. Okay? If I plug in negative 2, I get 2 raised to the negative 2 divided by 2 power. So, hold on. What is negative 2? Well, first off, what's negative 2? Positive 2. And 2 divided by 2 is? So this is 2 raised. Remember, that was an exponent. This is 2 raised to the first power. And what's 2 to the first? 2. Okay? Well, let's keep going here. 2 raised to the negative 1 divided by 2 power. Negative 1 is 1. And so we have 2 to the 1/2 power. What the heck does that mean? 2 to the 1/2 power is?
Negative 2.
Square root of 2. 2 to the 1/2 power means the square root of 2. Remember doing that? Rational exponents? Oh, yeah. Okay, let's keep going. 2 to the negative 0 divided by 2 power. Well, there is no such thing as negative 0. It's just 0. And what's 0 divided by 2? 0. So we have 2 to the 0 power. 1. 2 raised to the negative 1 divided by 2 power. That is 2 to the negative 1/2 power. Negative exponent, what does it want to do? Drop to the bottom. 1 over the square root of 2. Aren't these fun? And of course, that's not rationalized, but at this point, we're not going to have to worry about that. And then 2 squared. So 2 to the negative 2 over 2 power. That's 2 to the negative 1st. That's 1/2. All right. If this is the situation you find yourself in, you can easily graph 3 of these. Right? Okay. These guys are not so easy. But you know what? This particular problem, I probably wouldn't have you do without a calculator. This particular problem, if I gave this to you on a quiz or a test, it would be on the portion where you get to use a calculator on it. Okay? So then how would I know where to graph the square root of 2? Plug it into a calculator. Find the decimal approximation of that. 1 point what? 1.4. Close enough for me. Okay. And then how would I know where to graph 1 over the square root of 2? Again, I plug it into the calculator. 1 divided by the square root of 2 is 0.7. Now I know my decimal approximations. Now I'm able to graph this guy. And so I can go to 2, negative 2. 1.4, negative 1 is roughly in there somewhere. 1, 0. Whoops, I graphed something wrong here, didn't I? What did I do? Because 1, 0 is here. Something's looking funky. Oh, duh, my first point. That's not where 2 is. 2, negative 2 is there. All right. Continuing on, 0.71, somewhere in there, and 1/2, 2 is somewhere in there. So this is a very gradual graph. When you're doing this, please do not graph it coming out, then all of a sudden going straight across. This is a very gradual curve happening here, and so it would look something like this. Okay?